Every powerful storm begins the same way, quietly. At first it's just a cloud. Warm, moist air rises from the ground, slowly lifting into the sky. As it climbs higher, it cools and condenses. This process is called convection, and it's the foundation of every thunderstorm. At this stage, nothing feels dangerous. You might see a distant flash of lightning, hear a faint rumble of thunder far away. It almost feels peaceful, but inside the cloud, something important is happening. Tiny water droplets and ice particles are colliding, building up electrical charge. It's slow, but constant. Even though this stage looks harmless, lightning can still travel several kilometers away from the main cloud. About 10% of lightning strikes happen outside the rain area. This is called a bolt from the blue. So even if the sky above you looks clear, you might still be in danger. Globally, lightning strikes the Earth around 100 times per second. That's over 8 million strikes every day. This is level 0, the beginning, a storm with potential. Level 0 be like, I'm not a storm, I'm just vibing. Because if the rising air continues, this harmless cloud can grow into something far more powerful. Level 1. As more warm air rises, the storm begins to grow. The cloud expands higher into the atmosphere, becoming darker and denser. Inside, movement becomes more chaotic. Water droplets and ice crystals collide more frequently, increasing the electrical charge. And with that, lightning becomes more common. Thunder grows louder. Rain begins to fall more steadily. The wind starts to pick up. At this stage, the cloud can reach heights of 10 to 12 kilometers, higher than most airplanes fly. Inside, temperatures vary dramatically, from warm air near the base to freezing conditions at the top. This temperature difference creates instability. Meteorologists measure this using something called CAPE, convective available potential energy. The higher the CAPE, the more explosive the storm can become. At level 1, the storm is feeding itself, and the more energy it gains, the faster it grows. Level 2. Now the storm reaches a new phase. It becomes a fully developed thunderstorm. Inside, two powerful forces are at work: rising air and sinking air. As water droplets grow larger and heavier, they begin to fall. This creates a downdraft, a rush of cold air moving downward. When it hits the ground, it spreads outward, creating strong winds. Rain intensifies into a heavy downpour. Visibility drops. At this stage, rainfall can exceed 50 millimeters per hour. That's enough to flood streets in minutes. Flash floods can develop extremely quickly, especially in cities. And here's something most people underestimate. Just 30 centimeters of moving water can carry away a car. That's less than the height of a ruler. At level 3, the storm becomes more aggressive. Instead of rain simply falling, some droplets are pulled back upward. Strong updrafts lift them into freezing air, where they turn into ice. Then they fall again and get lifted again. Each cycle adds another layer. This is how hail forms. The stronger the updraft, the larger the hail. Some hailstones grow over 10 centimeters wide, the size of a baseball. They can fall at speeds over 100 kilometers per hour. That's enough to break glass, dent metal, and injure people. In some countries, hail causes billions of dollars in damage every year. At this point, the storm isn't just strong, it's destructive. At level 4, the storm begins to lose its balance. Up until this point, rising air, the updraft, was helping the storm grow. But now, the opposite force starts to take over. Downdrafts become stronger than updrafts. Large volumes of cold, dense air rush downward from the cloud at high speed. This air is heavier than the surrounding atmosphere, so it accelerates as it falls. When it finally hits the ground, it doesn't just stop. It spreads outward violently in all directions. This sudden burst of air creates powerful surface winds. Wind speeds can reach 90 to 120 kilometers per hour, and in some cases, even higher. That's strong enough to snap tree branches, tear off roofs, and knock down power lines. These winds are known as straight-line winds, because unlike tornadoes, they move in a straight path across the surface. But don't underestimate them. In fact, straight-line winds can cause damage over a much larger area than many tornadoes. And here's where things get even more dangerous. One of the most extreme features at this stage is something called a microburst. A microburst is a highly concentrated column of sinking air that accelerates rapidly toward the ground. When it hits, it spreads outward like an invisible explosion. Wind speeds inside a microburst can exceed 150 kilometers per hour. That's powerful enough to flip vehicles, rip apart structures, and completely change the landscape in seconds. Microbursts are especially dangerous for aviation. During takeoff or landing, aircraft rely on stable airflow. But a sudden shift from strong headwind to a powerful downdraft can cause a rapid loss of lift. This is why microbursts are considered one of the most dangerous weather phenomena for pilots. At the same time, rainfall becomes even more intense. Water begins to accumulate faster. Then it can drain away. Flooding spreads across streets and low-lying areas, turning roads into fast-moving streams. Electrical systems begin to fail. Power lines spark, and entire areas can suddenly go dark. At this point, the storm is no longer organized. It becomes chaotic. Multiple forces interacting at once. Wind, water, electricity, pressure. And because of this chaos, the storm becomes much harder to predict. Its behavior can change rapidly, intensify without warning, or shift direction in minutes. At level 4, you're no longer dealing with just a storm. You're dealing with a system that's starting to break apart. And in the process, becomes even more dangerous. Level 5. Now we enter rare territory. At level 5, wind shear changes everything. Wind starts moving in different directions at different heights. Instead of rising straight up, the storm begins to rotate. This creates a supercell, the most powerful type of thunderstorm. Inside it is a rotating core called a mesocyclone. Supercells are rare, but they produce the most extreme weather. They can last for hours, travel hundreds of kilometers, and maintain their structure the entire time. One example is the 2013 Moore tornado in the United States, which caused massive destruction, with winds over 300 km/h. At this level, the storm becomes something else entirely. Level 6, this is the peak. At level 6, everything reaches maximum intensity. Updrafts, downdrafts, lightning, wind. All of these forces are now working at their absolute limits, feeding into each other in a continuous loop. But the most dangerous element is rotation. Deep within the storm, rotating air begins to tighten, faster and faster. If that rotation becomes strong enough and extends toward the ground, it forms a tornado, a violently rotating column of air, connecting the sky to the surface. Tornadoes are classified using the enhanced Fujita scale, a system that measures their strength based on the damage they cause. It ranges from EF4 to EF5, the most extreme category. The strongest tornadoes, EF5, can exceed 320 kilometers per hour. At those speeds, cars are thrown like toys, trees are ripped out of the ground, and even reinforced buildings can be completely destroyed. And what makes tornadoes even more dangerous is how quickly they form. Sometimes they develop in a matter of minutes, giving very little time to react. In 2011, a massive outbreak in the United States produced over 300 tornadoes in just a few days. Entire communities were wiped out. Thousands of homes were destroyed. Events like this show just how powerful and unpredictable these systems can be. And even today, with advanced satellites, radar, and forecasting models, predicting exactly where a tornado will form remains extremely difficult. At this point, this isn't just a storm, it's a disaster.